if we look at the first print statement, right? So line at -3, 0, 2. So -1, -2, -3. So it's this array, and then it iterates 0 to 2. 0 to 2, 2 is not inclusive, right? So that's indexes 1 or 0 and 1, which would be 10, 7 for the first print, right? The second print would print this entire list, but because line up to 1, so this, because 0 is not included in up to 1, right? Or rather, it is included up to 1. This gets replaced by 1, 11. So then we get 1, 11. And then we have our 10, 7, 12, 9, 10. Good with that?
Yeah, thank you.
Yep. Alright. So what is the output of the following program? For a equals 0, 1, b equals 3, 4, c equals a, b, 8, and 11. And then a colon equals 2, b equals 5, print c. So all we really technically need to know is what is c. So c is a, b, 8, and 11. So based off that, we know that because a and b are of a variable type, these will effectively be treated as pointers, and then 8 and 11, right? So because the 8 and 11 indexes never get changed below c, we know that at the very least it's going to print 8 and 11, right? So now we need to pay attention to how a and b change. So if we want to think about it as pointers, so that means basically there's some point in memory where these two variables are pointing to. So in the case of a, it is 0, 1. That goes there. And then this other pointer would be pointing at 3, 4, right? It's kind of ugly, but we'll just pretend that it just goes over here. So that is 3, 4, right? And so we see the array value at each index is getting replaced by 2, right? So what that looks like is this entire thing just gets replaced by the value of 2 inside of a list. So if we were to update up here with that, right? So instead of a pointer, it would just be a list of 2. And so now we need to look at how b changes. So the variable b gets set to 5. The weird thing about this is because this was a pointer to memory, so in effect, it kind of looks like there's a pointer from here. Pretend that this is a down arrow. But then there's also a pointer for b equals here, right? So what happens here is this pointer of b equals this value just gets changed into b equals 5. But that does not remove the reference here of this b pointer in data pointing to this other array. This only happens with objects, of which a list is an object. So given that, our output should be 2 as a list, 3, 4, because that does not get updated, and then 8 and 11, because we also did not update that. Good on that?
Is that because the first B is a list and the next one is just a single integer?
Yes.
Not in brackets?
Yeah, because this one's an object and then this one is a primitive data type. And so it kind of gets back to that passing by value and passing by reference we've gone over a couple times. Good on that?
Yeah, and then also when you use the semicolon, that includes the end of
The colon?
range, right? Like it goes from 0 to the end included.
The colon, I believe, is just, it counts for every element. If you look at, I want to say it's discussion 5 or so, all these string operators, the notes given for that basically apply to any kind of indexing bracket as long as it is a native Python command. Alright, let us get on to the next one. So this one looks like an absolute headache to read, and honestly it kind of is. So we have a list, then we have this glorious, glorious line here, right? So reading through this, we have item divided, which is a floor division, 3 plus 2 for item in A if item modulus 3 is equivalent to 0. So you kind of have to read this out of order. So the first thing is it's actually a for loop, right? So for item in A, then we have if item modulus 3 is equivalent to 0, then item divided by 3 plus 2 gets put into B. Hold on, I'm going to move this to Notepad++ because it's easier to read. Like so. So the first thing we need to do is basically just see which values in the list of A are divisible by 3, right? So in this case, if we look here, we have 18, 3, 21, and 15. So then we need to figure out what we're doing with it. So item divided by 3. So this is floor division. Basically, that means if there's a remainder, we're getting rid of it. Plus 2. So 18 divided by 3 is 6. Plus 2 should be 8. 3 divided by 3 is 1. Plus 2 is 3. 21 divided by 3 should be 7. Plus 2 is 9. 15 divided by 3 is 5. Plus 2 is 7. And then we have x, y, and z. And so we end up storing it such that is 8, 3, 9, and then 7. And so that's just because of how this is arranged, right? So it looks a bit weird because there are 4 values that we need to save into 3 variables. But since x is defined as the first of these variables, right? So x would always take the first variable here, right? Because it is not a list, it is not a pointer, which means it can't take multiple values. So that takes 8, right? And then z is the final value, which means that 7 gets assigned to z. And then because there are 2 values left, but y is a pointer, which means that it is allowed to be an object, aka a list in this case, it then holds both of the middle 2 values. So you'd get this for your print statement. Good on that?
You can't have more than one star in like a multiple variable assignment, right?
We can test this.
You can also put a star on your z, right?
Oh, great question. Let's see. See. I don't know if you guys can read that red text, but only one unpack operation allowed in list. Which is basically means, yeah, you're not allowed multiple stars. Make sense? Cool. Moving on. So we have A equals a joyous thing. So A equals 1, 5, 3, right? Because these 2 lists are added together. Append means it's adding to the end of it. So it's 1. And then it extends by the array of 1, 3. So extend means that those 2 will get added onto the end. So it looks something like this. And then B equals the set of A. So the set is unique, which means that there can only ever be one instance of any given element, right? So B equals, so we have 1, 5, and 3 as unique elements, right? And then we have B dot add of 4, and then B dot add of 3. But we already have 3, which means that it is not, in fact, going to correctly add that, right? Because these are already unique. And then print B. So the elements we are expecting should be 1, 3, 4, and 5, which is C. Next one. Alright. So this is a dictionary, right? So we have a key and then a corresponding value. We have info, so that's the dictionary, getting accessed at age. So at the key of age, the value represented here is 21. So this will be 21. Name in info. So this is an if check, right, or a Boolean value of if name is in info, this will return true. Otherwise, it will return false, right? And so we can see here we added a key called name. So this will return true because this key does exist inside info. The next one is length of info. So that's the number of entries inside of this dictionary. So we have 1, 2, 3, because this one gets added after initialization. So that one would be 3. So we got true and 3. The next one is length of info at name. So info at name, so it would be this key value, which gives us this actual value here, which is Robert. So Robert's length is 1, 2, 3, 4, 5, 6. So length is 6. And then Rob in info. So that would be, is the key called Rob in info? And it is not. So that would be false. Good on that? Cool. Next one. So we have another dictionary, it looks like. We then have print of info.get of email. So the thing about this is whenever you do a .get and you have a second parameter here, this is the return value if that key does not currently exist, right? So if we look here, there is no email parameter. So info.get of email is not going to give us anything useful. It would error out in a way. But because we have this default value here, this is what gets returned because nothing gets found. So the first print statement should be admin@ufl.edu. We then have info.update of email, rob7361@ufl.edu, and then major is added for biology. Update is basically an add to the dictionary, right? So then we once again call that print info.get of email with this as the default clause, right? And so now the email clause is actually the key exists. So this will return Rob. Okay. And then this next one is print info at major and info at age. So major is defined now. It's biology. And then age is 21. But info at age is plus equal to 3. So that means it should be biology 24. Good on that?
If you use the update command and email, like in like one of the ones that you're adding already exists, will it just update the value,
Yes.
not the key? Okay.
Yeah. Because you're updating at a given key. So you can't really update the key because then you're just creating a new entry instead, right? You could
So that
technically,
function would just like add on to the dictionary, the key and value.
yes. Like that's what happened right here. This gets added as another key and value pair. Alright. Let us move on to these. So we have print the output of the list 1 and list 2. So we have a nested list. We have list1.append. So append adds it to whatever given list that it's given, right? So that would be inside here as a singular entry because it's not accessing list of 1 at 0, right? Because this would be list of 1 at 0. And then the other one, so we have list 2. So same starting point. So list 2 at 0. So it's this list at this 0th index. So now we're staring at specifically this list. And then dot append. And because dot append adds it to whichever list is in scope, it will add it inside here. Does that make sense? Alright. Let's see, this next one. So list of 3 is 1. List of 3 at 0 at 0. So at 0 means this list. at 0 of that is just the value 1. Dot append requires it be a list type. So this should throw an error because you cannot append a value to a non-list. Next one. Unless anyone has questions.
You could append if it was just like list underscore 3 0 throughout the second 0.
Yeah, so if it was list at 3 at 0 dot append of 1. So if we look again at this example, right? So it access at 0, right? So basically the scope that we're looking at from here is 1, right? And so because this is a list, we can append it. So it just becomes 1. Very similar to the first question we got. Good with that? Uh-huh. Alright, so print the output of the list 4 and list 5. So we have a list. We have list 4, -2, -2 equals 7. So we have -1, -2, and then because we are once again indexing in reverse, -1, -2. Right, so that would mean list 4 is equal to 1, 2, 7, 4, 5, 6. And then it asks us to print that, so it should look basically just like that. And then we can look at this other one. So list 5 is 3, 4, 1, 2, and 9. And then it has list 5 up to index 2 equals AB. So up to 2 means it is indexed as 0 and 1, right? And so because a string is technically also a kind of list, it can be iterated element by element here. So 0 index would be A, and 1 index would be B. So we'd end up with list 5 equals A, B, 1 or 2, 9. Right, because this is the first index, so the 0th index. And then this is the second one, which would be the first index. So those would be replaced by A, B, and then we have 2 and 9 still. Go on that?
If there were more terms in the string than what was indexed, would it be an error? Like if it was colon B,
So
maybe? Or would it just repeat like ABA?
So you're asking if I change this to say 4, what happens? It just overrides, right? So
Just as 1 and 2.
yeah, because you can't have more than just these 2 indexes, right? So you can override all 4 of these, right? But you still only have 2 values, so that's all that gets saved, right? So if I did like A, B, C, it will now do A, B, and C, right? But if I do A, B, C, D, E, then, right? So for example, if I did 0 to 1 with A, B, C, D, E, you'll see it replaces only the first element, right? And then A, B, C, D, E, 1, 2, 9. Make sense? Cool. Let's see, where are we? Number 4, I believe.
I'm confused.
Huh?
If you could go over it one more time really quickly. I'm confused as to why the print the output of list 3,
List 3.
that the 0, 0 doesn't work there, but that the -2, -2 on list 4 works.
Okay. Well, so
List 3, wait, what did you say it printed out?
this is an error.
Okay. Oh, it's the dot append that's the
Yes.
error.
The difference is dot append versus equals, right? So if we look at a value, right, here, so the first -2 iterates on this outer list, right? So it selects this element here, which is the -2nd index, which is still a list object, correct? And then we iterate -2 again on this, so -1, -2. So what value type are we now looking at? Is this a, is this a list or is this an integer right now? From negative 2, negative 2. It would just be 3, which is an integer. And so can you replace an integer value with another integer? Yes. So the difference here is, so we go at 0. So from this outer list, we get this element inside, which it will not let me highlight properly. But so bracket 1 bracket, is that a list or an integer?
Is that a list?
That's a list, right? So
Yeah,
then
bracket.
so then we can access at 0 again, which would get us just the 1, correct?
Yeah.
So is 1 a list or an integer?
Integer?
Can you append something to an integer?
No, it has to be a list.
Correct. So that's why this throws an error.
Gotcha. Thank you.
Yep. I forgot where we were. I want to say number 4. All right. So I have list of 6, A, B, C, D, E, F. So the list at 6, 2, 1 equals Z. So 0, 1, 2 at 1. Is this valid? Can I replace this here, this F with a Z? You say yes? So this has to do with, technically, if you do a double indexing here, you're treating it like a list, right? So it's a list at and then a list at, right? Strings, however, are not lists. So this throws an error because, as you can see, it does not support item assignment. There are technically ways you can circumvent this. I believe it is, if we want to say some kind of variable equals list at 6, and variable at 1 equals Z. I think this should run. Oh wait, it actually just doesn't. So strings at something. There is the character at that you can utilize for a string, or you can iterate over one, but this specific type you cannot.
I thought we were just saying though that it's like kind of like a list, and like if we wanted to identify a specific character in that like
Well,
registering real quick,
so what does a type error indicate?
it has to do with trying to like apply a function to the wrong type of variable. Right?
Yeah. So the thing is, lists are what we call mutable, where basically you can change items in their place, right? So like you can directly replace this element if you want to, right? So like list 6 at 2, you can replace it, right? However, strings, you cannot just change the little parts of it willy-nilly, right? So, for example, you could add to the string, right? You could do something like this. Uh, and then I would need to set list of 6 at 2 equals var. Alternatively, I could also do list at 6 plus equals z, and that would also get us the same desired result. I'll just do a y so that's easier to demo. Right, so that would just add to the straight list, and then at, say, 1, it would allow us to add to this, but we cannot directly just remove a part. That's why, if you remember, we did substrings, right? And then you do string manipulation from there.
Yeah, it was kind of like this during like the hexadecimal.
Yes.
Right?
Yep. So it's because strings are technically immutable, so you can't actually change that kind of stuff on the fly. So while they are technically a subset of a list, they have specific functionality, which causes them to act differently. All right. Exceptions, get, and ethics. So what is the output if the input is -2? So we see up here we have a try. Num equals int of input. So this is a valid value, so -2. If num is less than 0, raise value error of 555. So -2 is less than 0. So we'll raise a value error. So this try will get skipped over. And now we're looking at exception. Which exception should a value error raise? Any guesses on which error should be thrown out of these three?
Is it the value error?
Yep. So it'd be a value error. And so here it passes in this 555, and that would be passed in as this error here. So you could check something like, is error equivalent to 555? But as we can see here, it does not do anything of the sort. It just prints out 0, 1, 0. And then we also have this finally keyword. Finally basically means regardless of what you've done up to here, just print this out anyways. So the output for the first one is, welcome to assertions and exceptions. Print 0, 1, 0. Print 1, 2, 3. The next one is, what is if the input is 2? So 2. This one won't run because num is greater than 0. Array at num equals 6. Is this valid? Array is a list that was blank and created up here. So is this valid? No. What kind of error would we throw here? So it would probably be something along the lines of index out of bounds, right? So which exception would that throw? Yeah. Yep. So we'd get welcome to assertions and exceptions, print 1, 1, 1, and then as always, print 1, 2, 3. So then the last one, what if the input, or what is the output if the input is 2 but in word form? So if we pass an input here, then we have int, then this should be an integer. Is this line fine, or will this throw an error? Okay, what kind of error would it throw? It could be a type. It could also be a value error. So if we look up the difference, type versus value error, right? So a type error occurs when an operation is applied to an object of inappropriate type versus receives an argument that has the right type but an inappropriate value, right? So this is because input gets the correct value type, right? Yeah. Because you can't really pass anything into input that would actually cause it to throw a type error, right? But this is a value error because integer casting that is not quite supported. So we would once again get 0, 1, 0 for a value error. What was that?
So zero division error and value error are like not functions, but they're like terms that are in Python that like exist.
Yes. So exception is basically the very, very, very broad overhead for all the error types in Python. Theoretically, using exception is bad because you can manually throw a keyboard interrupt into some programs, and this will catch it when you probably don't want it to. Because if you want to force a program to end and you catch it like this, you'll run into errors. Well, rather, you won't run into errors, but you won't be able to kill the process, which is quite inconvenient. That's why it is strongly encouraged that you use the correct error that you are expecting. That way, if you get a different error, you also know that you have messed up in some kind of way. Okay. Let's go on to the next one. So, we have random dictionary. Random dict at C plus equals 3. Right, so this is key. Value is 2 plus equals 3 is 5. Right. We then have random dict at D dot add a 4, so 4, 5, 6. And then this would have a value added, except does it actually properly add a value here? What do curly brackets indicate here? So if it's a set and it's unique, does this line add anything? Rip. So nothing will happen there, most likely. And then we have print random dict at A5. So at A is this key, so we have this value. And then at 5. Is 5 a valid index here?
No.
So what error would we throw?
An index error.
So it would then print index out of range. Does this no problem line print? Correct. So because this is out of the try except, right, this will run just afterwards. So random dict.pop. Pop basically means remove an element from this dictionary and also return it. And so this E key does not exist. And so as we mentioned before, the second parameter is going to be the default parameter. So when it fails to print anything, we will then get no problem. Or it fails to find anything with this key, rather. Alright.
Isn't pop also like remove a random thing? Like a random value in the list?
It is not random in this case because you're checking for a key. If we're talking about like a stack or a queue, pop would be a designated location, either the top, aka the most recently added element, or the least recent, the oldest element would be removed, depending on what kind of data structure. But that's more in scope for later classes. For now, pop, you pass in a value. Alright, ethical questions. I'm going to very quickly breeze over these. Does anyone have any questions about where to find these slides? So this first one is true, false, false, true, true. Which of the following is an ethical behavior? If you can't figure out which one it is from here, I am concerned for you, very kindly. But accessing things while authorized is quite ethical, so C. And then for Git, here is a little diagram I decided to do before this class. So here we have our local repository, here we have the cloud, right? So if you want to create a local repository, you would use git init, right? Init stands for initialize, so you start it. Very similar to variables, you basically say this exists. It might not actually have any value, aka you might not have code in it yet, but it exists, right? And so if you want to make changes and then send it off to the cloud, right, you use git add, which creates what I like to call a watch list, right? Where it just is like, these are the files I care about, whether or not these change, right? And then git commit is basically when you take a snapshot of your current code status, right? And so then it'll go back and be like, which files are on the git add list? Okay, these ones. Let's see, how did these change? And then with those changes, you save them into a commit. Commits are usually accompanied with some kind of message descriptor describing what those code changes do. For example, added XYZ functionality. Right? So we've made a commit, but it's still currently on our local repository. So now we need to do a git push, and that'll put it to the cloud, right? If we wanted something from the cloud to get downloaded, we'd use git pull. And then we get into branch control, or version control, where we have a main branch, and then you can use git checkout to either create new branches or switch to branches, right? And branches would be if you don't want to mess up your main branch, which, for example, has implemented part B of project 2, but you have not finished 2C, and you do not want anything to break in between, right? So maybe you'd make a branch for 2C, you'd work all that functionality, and then you're like, this works. Everything here works up for 2B and 2C. So now you can confidently push it back into main. So you do git merge, so it all becomes one branch again. Good on that? Alright. So given that, imagine that you have a local repository, but other team members have pushed changes into the remote repository. So if we look at this, so we have a local repository, but some other team member made changes here. So what operation would we use to download these changes into our working copy, aka our local repository? So it'd be going from here to here. So this would be a git pull. So which of the following statements is not correct? The commit command is used to save your changes to the local repository. Well, we took a snapshot, aka we saved the current changes on our local repository. Commits are local until they are pushed. Well, if this first one is true and we saved it onto our local repository, then they are not on the cloud until we push them. A clone operation makes a copy of a repository locally. That's technically not on this little diagram, but this is true. You can Google it, or it's also on the slides about Git. A push operation pulls down any changes made to the repository. Well, a pull operation pulls down any changes made to the remote repository. So this is false, because this should be a pull. A push operation would push up any changes made from the local repository to the remote repository. Good on that? Alright. And now we get to classes. So, what is the correct way to instantiate an instance of Peer Mentor? So, we have a method blueprint of self, name, email, and then working hours, where working hours has a default value of 8. So that means self is naturally passed into these methods because they are a class. So we have 2 required pass-ins with an optional third one. So this one has 1 pass-in, this one has 0, this one has 2, this one has 2 and another integer value, and then this one's just wrong. So the answer is both C and D. So this third parameter can replace whatever variable is set by default in working hours. So say you put in 4 here, that class would then have the value of working hours equals 4. So the next question is, how do you call this instance method of run discussion correctly from this? And so this variable name called PM is assigned with the value of the object. So you would then call PM dot run underscore discussion. And so we see there's 2 parameters here, self and hours. So self is normally passed into itself, which means we need at least 1 parameter. So that would be 2. So PM dot run underscore discussion of 2. Let's see, next one. So we have print of peer mentor.payrate, Susanna.payrate, and then Oscar.payrate. So starting with the first one, so peer mentor pay rate. So we create 2 objects of peer mentor. We have a pay rate here, and then so Susanna.payrate gets set to 15. So this one will be 15. Then peer mentor.payrate is set to 14. And so that would be for the entire class, right? So that means this one gets replaced, right? So then the question is, does this one get changed? Should Oscar's pay rate be 14? Should it be 13? Or should it be 15? Any guesses? 14. That is correct. So the answer would be 14, 15, 14. Any questions on that before I move on? Okay. So moving on to this next one, what is the output of the following program? So this is a class definition. So Abhishanka equals peer mentor of Abhishanka. So that should be this name parameter. Email parameter 4. So that replaces this working hours parameter. Then we have print the class.weeklyPay. So weekly pay of self return pay rate times self.working hours. So we know what working hours is because it calls self.working hours, right? So that would be this variable that gets set up here. But we don't know what pay rate is because that's not defined within this method. So this would actually throw an error because this is not self.payrate. Good with that? Okay, we shall move on. Find the errors. So, looking at a couple things. So, capitals equals for capital in country underscore capitals dot values. This is technically incorrect format. Capitals dot add should be capitals dot append. If index is in values, you should be checking cities here because of the logic here. If you look at country capitals at city, this should be in reverse because you are utilizing the value instead of the actual key. And then the other thing is you're comparing an index as equivalent to a name. So this would be numerical values. And obviously, an integer is never going to equal a string here if it's Sophia. Any questions on the errors here?
What was wrong with the format of capitals equals?
For this one?
Yeah.
So what does this for loop do? If we pull this kind of code over here.
It addresses each key.
So why doesn't this work? Because clearly this is giving us some red text that is very, very angry at us about how these brackets are not closed. So why would that be the case? So what if we look at some of these other lines? So should this one be valid? Yes. So how would we put a for loop inside of here to iterate properly? There was an example previously if we scroll up enough. So what is different about this syntax?
Can you show them both at the same time?
The one
Sure.
that's at the top one actually like calls like actually executes something
So where is the execution line supposed to be?
before the for loop.
Before the for loop. So if we put like what, capital? For capital and country capitals dot values?
Nah, like capital would have to like be set equal to something or like
Does it?
some like I mean not
Well,
necessarily, but it's like what executes as the loop continues.
So what if I run this? Does that give us the correct stuff we want?
so like the output is the, or like what is added to the list is each instance, like each value.
So the left value here defines what you're adding.
Is like what's under the for loop.
Yes.
And then
So this is what you're actually inserting here. Because if we look here, right, this is the iteration here, right, for item in A. This is a conditional, right? But if there was no conditional, then it's just empty, right? Because you want all the values. So this one's optional. But this one defines what we're actually storing into the loop, right? So that's why you need this here. Does that make sense? Yep. Let's huh? Dot values. Where is this in reference to?
And country capital is values.
Oh, so dot values would mean the second part of these, right? So dictionaries are keys and values, right? So that's why if you notice here, the values it prints are all the values from each key, right? So Beirut, as opposed to Lebanon. Does that make sense?
Yeah.
Okay. Any other questions about this?
yeah, I think I might have missed this part, but for country for the Bulgaria equals what's the other part?
Okay.
Does it just create a new key and then it creates a new key and value?
So if I do this and put this up here, this is what you're asking about?
Yeah, like it adds it to the dictionary.
Yeah. Because this is a new key, right? And then this is its associated value. So Bulgaria would be added to the end of this dictionary with a value of Sofia.
So is that like identical to doing update dot country capitals and then doing Bulgarian Sofia?
As in like you could also do it as an append statement.
Like you can append to dictionary.
Yeah. I mean, if you want to check that, right? Dictionary append Python. Right. So if we just look here real quickly. So at a given key, you can append a value. Yep.
I was just trying to like before when you use like update and like it's like the key and value don't exist in the dictionary, you just add it to it. Right?
If you used update on a value that does not currently exist, yeah. So that would be like up here, right? Where we have a key that doesn't currently exist, and then it gets added. Same thing here, right? Does that answer your question?
Yeah, so it's like the same. It's the same.
I mean, this is a dictionary.
Yeah.
This is also a dictionary. So it's the same functionality there. Yep. Alright. So you should be done with that one. Next one. So we have a class called Splicer. And then we have underscore underscore init underscore underscore in caps. This should also just be lowercase. If you notice, it's missing self here, right? So it should be self then comma word. we also don't have a define statement anywhere in here, right? Because if these are methods, they should have a define called on them. The splice command here passes in self. You do not need a pass in self because that is given by the fact that you did a object here, right? So the object in reference here is where the self gets passed in.
If you don't reference the object, you need a put self.
As in just trying to call splice without the class.
Yeah, like
Um,
class. Like,
that would throw an error because if you notice this method is only in scope within this class, right?
okay.
There is technically a way you can do it by just utilizing splicer as the class name, but that's usually only used for static classes, aka instances where there's only one of them. And so those would only show up if you want to think about like math.pow, if you are at all familiar with Java. Math would be a singular class. Okay. And then the last thing is .self is both redundant and incorrect here because you cannot access self outside of within the class. So it's acceptable here, but not outside because this is just normal code. So that's the other error. Any questions on those? Alright. Let's move on to the coding questions. So given a list of integers, write a function num in sequences to return a list that contains the number of elements in each group. Group is defined as a sequence of adjacent elements that share the same value. So we should be quite familiar with this, assuming you did your project, considering this is the general premise of RLE, run length encoding, right? So you should be able to take a given value and then look at the next one, right, and see if it's the same. If it is the same, you ignore it in this case until you find the next one, right? So this is a run of 2, so you save the value 2. Here it's a run of 3, you just save the 3. 2, 1, 1, 2. I don't, unless anyone has any questions, I'm not going to go over this in a ton of depth because you should be able to understand how to alter your run length encoding code for count runs or saving the decoded RLE variant. Are there any questions about how you'd go about doing this one? Okay. We will go take a look at the next one then. Huh?
Explanation cover the output, or is that just them explaining?
That's just the explanation. Yeah, that's why it just says output is. This is basically to make it easier to understand how you go from this to this. Alright, Gabriel the Gator loves to choose his favorite color of the day based on the so 5 bags containing 5 random Skittles of 5 different colors. So, a function. Remember whenever you're writing something for code on your exam, whether or not it asks for a program or a function. If you do not define a function for a question that asks for a function, you will lose points. Right? Except one parameter. So we now know only one parameter, right? It has a given name, which means please define your function as such and do not come up with your own one. Right? And then the list represents the 5 bags at each one. So these are the 5 string values that you should utilize, not these colors. And then the function should return a list of strings. A list of strings, right? So it defines the return type. So you should not be using anything else. If it says you should return something, you probably shouldn't print anything unless it asks you to print something, right? Any questions about how you'd go about doing this one? Alright, we'll move on to the next one. So, Gator Protector is a password database which stores 8-digit numeric passwords in a 2D list. So 8 digits, and then it's broken up into 2 lists within a larger list, right? So write an encoder, which returns a 2-dimensional list. So you're going to take a string that looks like this, right? Then you're going to create a nested list, and then you're going to insert the first 4 digits into the first one, and the last 4 digits into the second one. Any questions on how you'd go about doing this?
So a 2D list is just basically just nested lists.
Yep, it's a list of lists.
And like it would be in the same number of numbers. Like the connector. I'm just talking out loud. I shouldn't say that. I got it.
Yeah, something like that. I mean, so it'd probably be something like this, right? You'd define a function, right? Because it says write an encoder function, encode of password. So a password gets passed in, right? And so we know the password would be an 8 length string, right? And then so we'd have something like the encoded password. You can choose a shorter variable name if you'd like, right? So it looks something like this, right, as the empty form. So one way we could do this is for I in a range of length of 4, we could do encoded password at 0 at I equals password at I, and then encoded password at 1 at I equals password at I plus 4. Then we need to make sure we have a very important return. So it'd probably look something like that. There are a couple other solutions. Oh wait, technically this is not correct because it's every other one should get saved. So you'd probably do something with a modulus of 2 instead. So it's like if I mod 2 is equivalent to 0. And then you change the indexing here and here. Let's see. A solution like this, right? So we have that double loop, or double list, sorry. And then we just iterate through all the values. And then if it's divisible by 2, that means it's odd, or sorry, it's even. So 0 is even, 1 is odd, even, odd, even, odd. And then you return. Any questions on that? Okay, we will move onwards. So write a class called calculator that emulates basic functions of a calculator: add, subtract, multiply, divide, and clear. This class has one attribute called value. Implement the following methods. This should be very, very, very similar to your 4-function calculator lab. The only difference is you just use an attribute inside of a class. So please note, it asks you to write a class. Do not write a singular function. Do not write a main. Just make a class. It should be called calculator. It should only ever have one attribute, right? So that means only one local variable within the class. And then everything else is as described. Any questions on how you'd start this? Alright. And then we have one last question. So you have been tasked with designing a class to store the grades of all the students in COP3502. Design a class called gradebook, has two functions. A constructor, so that should be that init function, right? Accepts one parameter grades, which means it should be self and grades. It is an integer list. And it also tells you what variable name you should store it as, grades. Another function called averages. No parameters. Note, no parameters. But it does return values. Do we know what a tuple is? Any questions about what a tuple is? Okay.
I understand what a tuple is, but like, how would you like call, like, how would you make it like in this situation? Like, so like, would you like have an empty tuple and then add stuff to it?
What's your question exactly?
Like,
So regarding a tuple,
yeah, like how would when we return the tuple, would be like we'd be adding values to the tuple, or is there a way to like make a tuple?
so let's see.
You have to like make an empty one first, right?
Yeah. So let's see. So this would return from a function called averages. So we'll call this averages. It takes no parameters but returns a tuple of the mean and median, right? So say we got mean equals 20, median equals 100, right? So we could do something like x tuple equals 2100, or sorry, mean, median, x tuple. Does that answer your question?
Yeah,
Alright. And then we have some other requirements, and that's it. Does anyone have any? Oh, go ahead.
Yeah. For that last one, when it's saying it's taking no parameters, does that include self?
So you'd probably put self here, because if this is within a class, right?